hypothesis of induced low entropy for fusion devices, a configurational key instead of the Lawson's criteria. An interesting fact. In the 1930s, both Rutherford and Einstein publicly called the idea of obtaining energy from the nuclear fission a utopia. They had their reasons for that, but just 30 years later, the first nuclear power plant began to provide electricity. The essence of the evolution of fusion machines in the increasing complexity of their systems, the growth in the number of controlled parameters, and the precision with which these parameters are maintained. Algorithms also become more complex. For example, following the evolutionary path of tokamaks, we see that feedback systems for magnetic fields were introduced. Magnetic field configurations become more intricate. All this to suppress plasma turbulence more effectively. In essence, this means preventing the growth of plasma entropy, which in language of Lawson's criteria is called confinement. Here lies the key point of my hypothesis. The main enemy that all fusion approaches fight against is the growth of entropy. Essentially, these measures reduce the degrees of freedom of the reaction medium. For example, plasma in space. Scientists are diving deeper into this fractal rabbit hole, but fail to see the obvious. While studying plasma instabilities, they already control individual vortices, and even subvortices, and so on. Now we come to the next logical conclusion of my hypothesis. If we extrapolate their efforts into the future, we arrive at ever smaller scales of control. And the smaller the scale of control, the more effective the control of the medium, plasma. This is in essence an attempt to induce low entropy through parameter control. Main principle of the hypothesis. The more parameters we control, and the more precisely we do so, the lower the required input energy for fusion.